And this takes us to this new class of RDTs called the pipeline protocols. Okay. What it said is, let me repeat myself, the sender allows multiple packets being sent per round, okay, or multiple packets in flight. By in flight, I mean that these are just data packets going out, they are not yet acknowledged. So it's illustrated better here. So this one on the left is stop and wait. This one on the right is the pipeline RDT. So we see multiple data packets go, not yet acknowledged, and their acknowledgements will come back in a sequence, okay, in a round to the sender. Okay, so a range of sequence number needs to be increased. So previously in RDT 3.0, we used just one bit, right, 0, 1. But now we need to allow multiple packets going out simultaneously. And we need to make sure that we acknowledge each of these packets. So we need to tell each of these packets in flight apart. Well, the sequence number definitely needs to be expanded. And we'll need buffering at the sender and the receiver side as well. Because, hey, what if multiple of these packets in flight are dropped? They need to be retransmitted again. So buffer definitely at the sender side is required to store those packets that are not yet acknowledged. Receiver here will also need buffer space because when this packet is lost and there's other packet coming in subsequently, should we keep them or should we drop them and have the sender retransmit again? And what about these other packets that has already arrived? Okay, so there's some buffer space also, okay, needed in order to address different needs of different designs. So buffering required, a longer range of sequence numbers required. Okay, now in the next few slides, what we're going to introduce are just two different flavors of these pipeline protocols. So they are the big categories. First is the go back N. The second is selective repeat. Now one can of course further tune the go back N so that it works slightly differently. Hopefully the second version works slightly better than the fundamental version. Similarly for the selective repeat protocols. Okay, so here's the overview slide that contrasts the two big categories of pipeline protocols. On the left, the go back N. On the right, selective repeat. Right? They are the same this way. Okay. Both of them allow having multiple packets in flight in a round. Okay. Well, that's the basic ideas of pipeline protocols. They must be the same this way. And then everything else will be different. First of all, okay, what the sequence number in the ACK packet means, very different. One is to indicate I'm acknowledging an individual packet. So when the receiver in selective repeat sends an acknowledgement, that sequence number in the acknowledgement is to acknowledge exactly the data packet carrying that sequence number. But for go back N, the receiver sends back acknowledgements, but the acknowledgement carries a sequence number such that all the data packets before that sequence numbers are acknowledged. So this is a bit odd. Okay, so that one sequence number seems to be acknowledged all the packets before that. But the fact is that what the receiver is doing is this. Okay, the receiver will not add packets if it arrives and the receiver finds that there's a gap in between. So packet 1, 2, 3 missing, 4. Okay, when 4 arrives, the receiver does not send back acknowledgement 4. Instead, it sends acknowledgement 2 because there's a gap in the middle. So what the receiver of go back N here is saying is, I'm actually telling you to which point I do have consecutive received data packets. Okay. So the next one is, the beginning of a gap, definitely. And the two categories work also very differently here. Timer. Okay, if you recall in RDT 3.0, yeah, we need a timer in order to tell whether a packet is dropped or not. Yes, go back in and selective repeat. Both of them implements timer. Okay, but in selective repeat, there's one timer for each packet that is still in flight, not yet acknowledged. Okay, so one timer, one packet. But for go back in, there's only one timer for the oldest unegged packet. So in one round, there'll be a lot of packets being sent, multiple packets being transmitted. Okay, there's going to be just one timer for the oldest unegged, meaning if you send one flight out, there's just going to be one timer for the first one in that flight. Okay. And if the first one is acknowledged, there will be a timer for the second packet, that is now the new oldest packet that's not yet active. Okay. So, yeah, one timer for a flight of packet in go back in. And the last difference is this. Okay. For selective repeat, when timer expires, the sender only retransmit the unegged packet. So whatever that timer says, if this is for sequence number 10, then it only retransmits packet 10. But in go back in, when the timer expires, it's going to retransmit from, that oldest unegged packet. So all the unegged packets from the oldest one to the newest one. All right, so each timer is going to trigger retransmission of the rest of the flight of the packets.